Okay, so we're going to be working questions 5 through 12. But before I look at question 5, let's take a look at something. Let me show you guys something really quick. Let me draw a circle. And let's assume that's a circle. And let me draw a 90-degree corner, but not in the center of the circle. It's actually, I want this 90-degree corner, the corner touching the circle. So let me use red for my 90-degree corner. So something like that. This is 90 degrees. Now, interesting part is that this arc, this angle makes this arc. And yeah, that's definitely not 90 degrees, right? So now my number is not the same. My corner, my angle is 90 degrees. But interesting is that, let me draw with blue. If I was to connect these two lines, it's going to be a diameter, okay? That will happen always. A 90-degree angle will touch, if I connect them, it's going to create a diameter. So that means my angle on the outside here, it is 180. Okay, so look at the angle, the corner, the angle is 90 degrees, but the arc is 180, not the same number. Now, how can we figure it out? How can I go from 90 to 180? Just double it, right? If I give you the angle, and I ask you for the arc, just double it. Now, if I give you the arc and I want the angle, just cut it in half. When I say angle, I'm talking about the corner, right? The 90-degree corner. When I say arc, I'm talking about the distance outside of the circle. So again, if I give you the angle, angle times 2 equals the arc. If I give you the arc, arc divided by 2, it's equal to the angle. Now, for my purpose in questions 5 and 6, because it says the circle is centered on point P. So let me draw a circle. Let's assume that's a circle. And the center is point P. So the circle is centered on point P. Points J, K, and L lie on the circumference. So that means those 3 points are somewhere on the edge of the circle. So let's just say here's point J, here's point K, and let's say here, this point L. For your homework, I will give you the figure, but right now I had to graph it, okay? So interesting, let me use red. I see an angle here. And it's telling me, I read here, the measurement of angle JLK is 15 degrees. Okay, so I know this angle right here, it is 15 degrees. So just before I move on, I'm going to say the arc JK is going to be 30. You guys might be like, well, where does the 30 come from? Well, the angle was 15, so the arc must be 30. Remember I said a few seconds ago, I said, if I gave you the angle and you want to know the arc, double it, right? 15 times 2. Okay. Now, here it says, find the measurement of arc KJ. Oh, well, I already know it. 30 degrees. Nice. Okay, let me erase this information because I'm going to use my same graph for question number 6. Let me erase that. So I'm using the same graph for question number 6. Now here it says the measurement of arc KJ is 20 degrees. So the arc KJ is 20 degrees. If I wanted to know this angle, we can say 10, right? Because remember, if I give you the arc, the angle's half of it. Now let's see, what do I have here? Find the measurement of angle JLK. Well, I already knew that, 10 degrees. Now, Let me give you another example, because I could have even asked, find the measurement of angle JPK. You're like, well, where's that angle JPK? JPK, it's right here. Now, in this case, my angle JPK will be 20 degrees. Remember, yesterday we talked about the central angle. The angle in the center is equal, the degrees of the angle in the center are equal to the degrees of the arc that it makes. Yeah, this angle right here is 20. All right, so you guys are going to have fun in your homework. Some of these questions. Let's say question number 7. Now, these are pretty fun. Question number 7. Find the measure of the arc or angle indicated. So I'm going to play around. I'm going to look at the numbers, and I'm going to say, all right, I see an angle. So let me think of my angles first. I see an 83 degree angle. That's this angle right here. That makes this whole arc. Okay, I know 83 times 2 is 166. So the whole arc is 166, right? I have to multiply the angle times 2 to get the arc. But I know part of the arc is 46. So I'm going to say the remaining. So the arc ZD is 120. And let's see, what else can I figure it out? I know 46 is this arc. 120 is this arc. 100 is this arc. Let me highlight in green this arc. If I was to add all the yellow ones, so 46 plus 120 plus 100, I know it's 266. So the 3 yellow ones is 266. Like, so I just added 46 plus 120 plus 100. I'm gonna say the green arc happens to be 94. Because I know the whole circle is 360. The yellow part was already 266, so I just needed 94 more to complete the circle. So the green arc is 94. Okay, so I played a little. Now let me see what I've been asked for. Find the measure of the arc or angle indicated. Now I'm going to indicate what I need with the question mark. Okay, let me call it X for right now. So this angle X. It's an angle, so I follow along. I follow this line right here, and I follow this other segment right here of the arc of the on my angle, and I notice that it creates this arc. Now that arc, 94 plus 46, I know it's 140. Now how big is the angle? Remember I said earlier, if I give you the angle to get the arc, double it. If I give you the arc, so right now the arc is 140, to get the angle, I'm gonna say 70 degrees. This angle right here is the half of 140. All right, that was not that bad. Let's take a look at number 8. Okay, so let's see. I see an angle 52 degrees. That's this angle. Some of you might be wondering, or is it this other angle? No, the other angle definitely looks more than 52. Okay. If I follow along, that's this angle. So I'm gonna say this arc right here is 52 degrees. No, my bad, not 52, 104. I guess I have to go 52 times 2. So, okay, I know that's 104. Now I'm wondering, how big is this? let me highlight in green that I know this is 104. I know the 104 is the green one. I'm wondering how big is the yellow arc? Well, it seems like combined has to be half of a circle, right? And isn't half of a circle 180? I know 180 minus 104 is 76. So I'm gonna call this arc 76. Because I know combined, those two arcs combined is 180. So there, I figure that this arc is 76 degrees. Done. Now let's take a look at question number 9. We're gonna be dealing with the angles inside of a circle. This is what I'm going to do. Okay, let's pretend this is a circle. And then I'm gonna draw two arcs or two segments, not necessarily in the center. Okay, not necessarily in the center. Interesting is that these two angles are equal. Okay, so as soon as I find one angle is equal to the other one, remember vertical angle theorem. And there's an X form, opposite angles are equal. Okay, so that's one thing. I know those two angles, but this time I create two arcs. Like this angle creates this arc and this arc. What I'm going to be doing, the way I'm going to figure this thing out, I'm going to go 2 times the angle. It's equal to the one arc plus the other arc. So I'm going to go 2 times the angle. It is going to be equal to the sum of the arcs. I'm going to add the arcs. So the angle is always the corner, okay? Even though everything is in degrees, the angle is the corner. So I'm going to go, in this case, let me call that question mark X. And I'm going to go 2 times 116, because 2 times the angle, it's equal to X plus 97. Remember here in the instructions, find the measure of the arc or angle indicated. 2 times the angle equals, and then I add the arcs. The rest is just algebra. 2 times 116, that's 232. So I have 232 is equal to X plus 97. To get the X by itself, this plus 97, let me move it to the other side as a minus 97. So I get that 135, it's equal to X. Remember, I call X the measurement that I was looking for. Okay, so X equals 135. Done. Now, one more thing. I can play in your homework. I can ask you for the arc CB. Or I can ask you for this angle right here. One thing I want you guys to remember, the vertical angle theorem, when there's an X formed, opposite angles are equal, but adjacent angles add up to 180. So I could just come and say that this red angle here, it is 64. Okay, the reason why, because those two angles in the center have to add up to 180. So remember that. You guys are going to use that in your homework. Let's take a look at another example here. I see my X is right here. So I'm going to go 2 times the angle, all right? So in this case, 2 times 80 equals, and then I'm going to add the arcs, 95 plus X. That question mark, I call it X, because every time in math, when we don't know the value of something, we replace it with a letter. I know 2 times 80 is 160. So 160 is 95 plus X. To get the X by itself, let me subtract 95. So I have that 65 is equal to X. Boom. There you go. We're done. Now, question number 11. I see my two segments here. My angle is this one right here. I don't know what it is, right? There's a question mark. So I have to go 2 times the angle. So let me go 2 times x equals, I have to add the arcs, right? These two arcs. So I'm gonna go 115 plus 65. So I have the 2 times x is equal to 180, right? 115 plus 65 is 180. Let me divide both sides by 2. So x is equal to 90. Yeah, it looks like 90, so we're good. Now, this one, question number 12, I want to do number 12. What happens if the angle is outside of the circle? It still creates two arcs. You guys see it? Right, there's two arcs and there is one angle. I'm still going to go 2 times the angle. So kind of like what we were doing before. 2 times the angle. The angle in this case is x. So 2 times x equals, but in this case, I'm not going to add the arcs. I'm going to subtract them. Angles are positive, so I'm going to go with the big number minus the little number. So 140 minus 70. When the angle is outside of our circle, we subtract the arcs. 2 times the angle, but in this case, we subtract the arcs. 140 minus 70. So I have the 2x. 2 times x is equal to 70. Let me divide both sides by 2. X equals 35. So cool. I can still solve it if the angle is outside. See, that's what we did today.